part 11. So last week we talked about the nested or sub-queries. Fine, we could talk about this scalar sub-query, a row sub-query, and a tabular sub-query, and before that some SQL set operations, which is union, intersection, and difference. Okay, we taught this when we discussed this from the exercise 11.1. So after this topic we have a recommender system. So this is a different topic here, a recommend, which is basically talking about how the things are recommended on based on what data the things are represented or recommended on any platform. Like for example, when you make online purchases, you see that after you make some online purchase, then you start receiving the recommendations. You start receiving new products, something new, items, which is what you make the previous purchase. Okay, and sometimes it is more related to your profile, what you set in your profile. So that is what the recommender system will do. The recommender system will provide a recommendation for some products, or you can say for some items. Just a minute, please. It's a prayer call here. Okay, so this is recommender system are widely used on web. Like we have e-commerce website like Amazon or Noon or eBay, right? Any online web applications, we see that these recommender systems are used. It serves two important functions. They help the user deal with information overlaid by giving them recommendation of products and services rather than user having to evaluate each option by themselves. So this recommender system will help in getting the recommendations of products and services based on what product is being purchased previously or what is the profile of the user, okay, or what user may like. It also help the business make more profit by selling more products, since the recommender systems make products and services, right? The recommendation goes to the users, and users will get a chance or will get a choice to purchase the items. Okay, so in that case, these websites will make more profit. The business will make more profit. So this is the two important functions of the recommender system. Moreover, the most common scenario in retail sector is this one, for the user rates the products from 1 to 5 that they have purchased, and these rating will serve as the input. This will show you that whether the user liked this product or he did not like this product. Okay, so user rating on a scale of 1 to 5 becomes an input. The recommendation system uses this rating to predict the rating that each user would give to those products not purchased by him or her. The recommendation of products are then made to each user based on the predicted ratings. So if I am giving for any product, for example, let's say I purchase, I purchase an Android phone, okay, and I gave 5 star. So meaning that I am like there is a chance that I like the Android products from the same company from which I purchase. So recommender system can offer me some Android products like a watch, for example, or headphones, okay, or any such products related to what I purchase from the company based on my rating. Okay, so this is how it works. There can also be additional attributes about the user purchase and the item, about the user and the items, such as, for example, what is the age of the user, what is the gender, what is the income, what is the marital status, right? For about gender, right? So if I am purchasing a mobile phone, right, and my gender is male, then I prefer those items which are more likely to purchase by male, okay, because depending on the color of the product, okay, or the size of the product and so on. Okay, it also about the items, the item description, the type of item I'm purchasing, the cost of item, the manufacturers. For example, I'm purchasing at a cost of 1,000 to 2,000. So what products is recommended is between these cost. Okay, so this is how the recommender systems will work. They takes the input from the user actions. What the user make an action, they take the input from there and they make some recommendations. So there are many approaches to this recommendation system, but we'll see here two approaches, which is content-based recommendation and collaborative filtering. Content-based is it is the user will be recommended items similar to preferred in the past. Okay, what I purchased in the past, similar type of items will be preferred. For example, I purchased the tissue paper from company Fine, okay, in the last month. So this month also Fine products will be recommended for me. Okay, this is what a content based. So based on my content, what I purchase, what is my recommendation is again the Fine products, because the purchase what he made may be enough for 1 month, and after 1 month, if I'm looking for something like tissue paper or something, I'll get the Fine product recommendations. Okay, this is content-based recommendations. Second way is collaborative recommendations, where the user will be recommended items that people with a similar taste and preferences have liked in the past. It depends on the profile, the user profile. So what is the user profile? Based on it, the items are recommended. Okay, we'll consider the content-based recommender system in this module. Okay, so the recommendations are determined like this: perform item recommendations by predicting the utility of item for a particular user based on how similar the items are those that he or she liked in the past or purchased in the past. Okay, so based on that, recommendation system will recommend the products. Right? In example, online retail recommendation application of product may be represented by such features like description, type, cost, manufacturer. The user interest preference was also represented by same set of features called user profile. So data can be taken from the product, what is the type of the product, what is the cost, the manufacturer of the product, and so on. And also data can be taken from the user profile. What is the taste of the user, or what he likes, what he don't likes. So recommendations are made by comparing the user profile with the candidate items expressed in the same set of features. So top n best match or most similar items are recommended to the users. Okay, so one product will be selected, product we make purchase or we liked previously, and our profile will be taken, and some calculations are done, and to see that which products are more likely to be purchased by the user again. Okay, and those products, the top 10 best match product or similar items will be recommended to the user. So this is how the recommender system works. So we'll take an example here. Now, before we go to the example, we'll take the approach, like the content-based approach, how the similarities are calculated here between the items. Because when we say to purchase the items, how the similarities will be calculated. Fine. So the simplest approach of the content-based recommendation is to compute the similarity of features of a favorite item with each other item. So I purchase item 1. Okay, it has some features. It has features F1, F2, F3, F4, 4 features. Now I already purchased this. So the new recommendation will be like comparing these features with other items. Let's say I have there is item 3, there is item 2, there is item 4. They also have some features. Okay, F41, F42, F43. Item 2 will also have some features at F21, F22, F23. Item 3 will also have some features F31, F32, F33. Now these features are compared, okay, to with the feature what I of the product what I purchased. So which is the best matching feature? For example, F21 is best matching with this, then this will be considered. Similarly, F22 will best match with this, then this will be considered. So like this, every feature of every item is compared here to select the best item, to select the best item. So for example, given 2 items, X is a favorite item or user profile, and Y is another item with n features. The similarity of X, Y can be expressed as F1, the feature 1 between X1 and X and Y, F2, Fn divided by n. Okay. So between 2 products with the value of 0 and 1, with the value of a range of 0 and 1, from 0 to 1, 0.1, 0.2, or 0.3, something like that. So let's say there are 2 items, item X and item Y. So with n features. So how we compare the similarity, how we check the similarity is in this fashion. It is an average of all the features. So the average will range from 0 to 1. We add up all we add up all the features rate from 1 to 1, 0 to 1, either 0 or 1. Then we add up all them to find the value. So if f of I is multi-value property, if it is a single value property, that's fine. If it is multi-value property, then there will be a fraction value of y in x, which gives a range between the range 0 and 1. If f of I is a single value numerical property, then its value between x and y, which is expressed as in a range of 0 and 1. And if it is single value non-numerical property, then it will be 1 if the value of x and y are identical, otherwise it will be 0. Okay, so three possibilities. It is multi-value property, okay, or it can be a single value property, or it is a non-numerical property. In case of non-numerical property, we'll take 1 if they are identical, if the feature between x and y product is identical, we'll take 1, otherwise we'll take 0. Right? So if it is multi-value property, then it goes in the range of 0 and 1. And if it is a single value property, that can also be expressed a normalized difference in the range of 0 and 1. We'll take an example here, a simple example. Let's compare three movies. One we already watched and enjoyed, which is movie X. There are other two movies, Y1 and Y2, that we think we might enjoy, but we like to check before we pay to see them. So we want to use a recommender system here, that we want to check which movie is best for us, which movie we can like. We already liked and enjoyed movie X, and we have Y1 and Y2, two movies that we want to watch. So before we want to pay for these movies, we want to apply a recommender system, okay, the content-based recommender system, to check the similarity between X and Y1 and X and Y2, to see which is the most similar, so that we can buy that movie and we will enjoy. So let us compute a measure similarity of favorite movie and two other movies based on directors, its actors, and the audience rating. Okay, so for directors, Y1 has the same director as X, so the director factor is 1 because it has the same director. Y2 has a different director, so the F director factor is 0 here with compared to X. So the director factor with Y1 and X is 1 because they have the same director, okay, and Y2 with X is 0 because they have different directors. Okay, so that's a non-numerical value. So we'll take 0 or 1. Compared to the multi-value property, which is actors, there are 20 actors in the movie X, 16 whom are appearing in Y1. So what is the factor? 16 by 20, which is 0.8 for Y1. And 5 are appearing in the Y2 movie. So the factor will be 5 divided by 2, 0.25. The factors will be 0.25. Now coming to the ratings, the rating is a range of value from 0 to 5. So we need to normalize it, like 5 minus 0, 0 to 5, so 5 minus 0, mod with minus the absolute of x minus y divided by 5 minus 0. Okay. So here we say that the rating of x is 4.8 and y1 is 4.5. So the rating between x and y1 is 0.94. Calculate like this by using this normalization formula. And y2 has 3.5 rating and x has 4.8, so it will be 0.74. So we find the values of these factors. Three factors we are considering here. One is director. So director, let me put it in a form of table here. So three factors for movie X, Y1 and Y2. We are considering three factors, which is director, then actors, and rating. We find that the X director and Y director are same. So it is 1 here because the X director and Y director are same. So fine. And we see that the actors in X, there were 20 actors, out of which 6 by 1. So 16 divided by 20 is 0.8. Okay, the factor here. And the rating for Y1 is 4.5. And the rating of X is 4.8. Okay, so if we can normalize this, because it is a range value, so we apply this formula 5 minus 0, because the range is from 0 to 5. So 5 minus 0 minus absolute of X minus Y, that is 4.8 minus 4.5 divided by 5 minus 0. So that leads to the value 0.94. So it is 0.94. Similarly, we calculate between X and Y2. In X and Y2, the director of X and Y are different. Y2 has a different director. So it is 0 here. And now Y2 has only 5 actors, which is similar which are in YX. So it is 5 divided by 20, which is 0.25. And the rating of Y2 is 3.5. So we apply 5 minus 0 minus absolute of 4.8 minus 3.5 divided by 5, which is 0.74. Okay, so these are the values in comparison with X, movie X, with respect to the director factor and the actor factor and the rating factor. Now we'll calculate the similarity. We'll take these three factors. The first with X with Y1. What is the values? 1 plus 0.8 plus 0.9. 4 divided by 3. Three factors we are taking. So it leads to similarity 0.91. Now we'll calculate the similarity between X and Y2. So it is 0 plus 0.25 plus 0.74 divided by 3, which lead to 0.33. So which is more similar here? Which movie is more similar compared to between X and Y with respect to X? Sorry, between Y1 and Y2 with respect to X, which is the highest value 0.91. So movie Y1 will be recommended here. Y1 will be recommended. So from the above results, we seem to be more likely to enjoy movie Y1 than Y2, because Y1 has same director and many actors are similar, and the rating is also close. So this value is the highest in any grade, like nearest to 1 compared to this value. So Y1 will be more enjoyed. Okay. Yes, Faraz, do you have any question? Yes. Now, يعني هو نشوف الفيتشرز او الفاكتورز. مثلا الاكترز فيها 16 اكترز نفسه في الموفي اكس والموفي واي، فهي ممكن الاكترز نفس 16 يعني. اذا شفت الواي 2 بس 5 اكترز اللي موجود في الاكس موجود في الواي 2، فهنا هيفرق الارقام، يفرق الفاليوز. Okay. So we saw this. This is a simple approach to compare the similarity between two items. Similarly, we can compare like this. Okay, where we probably need at least to consider applying different weightings to each feature, because every feature will have a different weight. Okay, it is we simply calculated the values here in this, fine. But sometimes the weight of the feature may be different. For example, what is the role of actors in the movie? So actor plays the main role. So weight of actors in the movie, okay, is high compared to the other features. So for example, we when we watch the movie, we say that okay, we like these actors. Okay, we like these actors, so we watch the movie. Fine. So actor feature is more heavy here, and compared to the director, we don't know much about the director. Okay, very few people know about the movie directors, who is going to direct the movie, a good movie or a bad movie, something like that. So director factor is less, and the weight of director factor is less compared to the actor. Okay, similarly, we also look for rating. So we see that highest rating movie, we want to watch highest rating movies. So the weight of the uh, the rating is high. Okay, so we say, for example, 50% of actor, the weight of factor or the feature of actors is 50%, director is 10%, and rating is 40%, something like this. So it is also that chance that, for example, uh, when we apply these features, we may apply with different weights. Okay, if we feel that the director of a movie has more influence on linking the movies, then we'll apply a higher weight to the director than the actors. And if you feel that actors are having more influence in watching the movie, then the actor will have the more influence. Okay. So this is all about the recommender system. There is an activity on this. You can check this activity 11.3. So as a summary, what we have in this part 11 is about the set operations, that is union, intersection, and difference, that we discussed in our last meeting. And it has about set subqueries. Okay, we discussed in our last meeting, and one recommendation system, content-based recommendation system, that we discussed. That is, the recommendation is applied based on the features and the value of the features. You may ask about this recommender system in the exam. There is a chance that they may ask you about the recommender system in the exam. Okay, so you have to be prepared for that. So this is all what we have here for you in part number 11. Okay. Similarity تبع ايش؟ طيب ممكن اذا features يكون نفس الفيتشرز بين البرودكتس. اوكي، احتمال يكون بيطلع نفس السيميلاريتي. اوكي، ايوه، حسب الفيتشرز. فممكن يطلع نفسه. اوكي، بس هذا بس الاكزامبل، نقارن بس اثنين برودكتس او اثنين ايتمز. ممكن هنا نقارن اكثر من واحد ايتم، لانه لما نشوف السيستمز مثلا زي الامازون، او زي the applications e-commerce زي امازون او نون او اي هيرب او اي باي. اوكي، دائما لما نشتري حاجه بيجي recommendations. طيب احس على recommendations ما يجي واحد ولا اثنين، بيجي عده recommendations، ممكن 15 20 recommendations الايتمز. اوكي، فهذا recommendation حسب المحتويات او الفيتشرز بين اللي اختارنا البرودكت والبرودكت اللي موجود في في الابلكيشن نفسه. اوكي، فهذا احسب السيميلاريتيز بينهم حسب الفيتشرز وحسب كمان اليوزر بروفايل. اوكي، اليوزر بروفايل برضو يدخل فيها. هنا ما اخذنا يوزر بروفايل في الاكزامبل، ولكن في اليوزر بروفايل برضو بيدخل، لانه يوزر ممكن ميل، يوزر ممكن فيميل. ففي بعض البرودكتس خاص في الميلز، في بعض البرودكتس يخص للفيميلز. فهذا برضو بيدخل في الريكومنديشنز. Okay. Now we'll move to part 12, which is talking about data integrity. This is very important part, and this is something conceptual, and also how the system works with the data, right? And how the integrity of the data is maintained, the consistency in the data is maintained when we are doing the transactions, when we do the transactions. So in this part, we focus on how transactions and concurrent transactions are supported through SQL in a relational database. Transactions mana انه الانسرت والابديت اوكي او اي ترانزاكشن في الداتابيس اوكي the card operation مثلا في الداتابيس اوكي مثلا بنزيد البيانات وناخذ البيانات نعمل ابديت في البيانات اوكي او concurrent transaction بمعنى انه اذا في اكثر من واحد يوزر يعني if there is more than one user لاكسس نفس الداتابيس اوكي في نفس الوقت فكيف هيكون العمليه هناك والترانزاكشنز هناك اوكي في الداتابيس ممكن انا كيوزر 1 بدخل في داتابيس في الستودنت سيستم اوكي ونعمل تحديث البيانات في الستودنت حق الستودنت اوكي S1 في نفس الوقت في يوزر 2 بيدخل ابغى اشوف البيانات حق S1 فهل هذا يوزر 2 بيشوف البيانات حق student 1 بعد التحديث ولا قبل التحديث؟ إذا شوف هو بعد التحديث يحس البيانات إنه حدث البيانات أوكي الجديد. إذا هو شاف قبل التحديث هو بيشوف البيانات قبل التحديث يعني البيانات اللي ما في updated okay old information or the information which is not updated فهذا في concurrent transaction so كيف نعمل هذا العملية concurrent transactions so we'll focus on transaction and concurrent transaction. In this part we'll consider transaction and concurrency supported for a centralized database centralized in a واحد database okay so we have multiple users في user 1 user 2 user 3 ممكن لواحد database فكيف نعمل ال concurrent transactions فيها اوكي في البارت 12 هنا في part 12 part 17 we'll talk about distributed database and concurrency support mechanism for distributed database distributed in the sense a database موجود في أكثر من واحد سيرفر اوكي فالموزع database موزع اوكي فالفي users أكثر من واحد فكيف نعمل concurrency في هذا المجال في distributed system نشوف في part 17 we'll see in part 17 so this part will conclude a brief discussion of some of the factors that have an impact on the efficiency of SQL query execution and how query may be optimized by the DBMS. So coming to the data integrity, this part is divided into 4 sections. Number 1, transaction support. Number 2, concurrency support. Number 3, database failure and recovery, and query processing and optimization. So all these related to data integrity. Transaction support describe how DBMS maintains data integrity by ensuring that each transaction either succeed completely or fail without changing the state of the database. Any transaction we make and any update we make, any insert we make will be succeed completely or will fail completely without changing the state of the database. If it is fail completely without changing the database, or if it succeed completely with changing the state of the database. Okay, that is a transaction support. Concurrency support will describe the problem associated with concurrent transaction, the mechanism employed by DBMS to ensure data integrity is maintained. If more than one user is accessing the database, how it is possible that more than one user can access without affecting anything. Okay, that will be checked here. Then the third thing here is database failure and recovery. We'll describe type of database failures that could cause data integrity problems, or examine some mechanism to recover these types of failures. And query processing, this will describe the factors that influence the efficiency of SQL query execution. Okay, the main topics over here will be these two: transaction support and concurrency support in data integrity. When it comes to transaction support, fine, we are talking about when we make any transaction into the database. Transaction means here any updates or any CURD operation, create or update or retrieve or delete operation, any operation we are making inside a database. This operation should be either successful completely or it fails completely. There should not be partial transaction done. And we'll do this by taking an example. So let's see this from the activity 12.1. So here, from the book of Punaya, data chapter 15, data integrity, it talks about this concurrent transaction or transaction support. Okay, so transaction processing must, in maintaining the and assuring the accuracy and consistency of the data over the transactions, and it should follow the ACID properties. Fine. So we'll discuss this with an example here. For example, let's say that we want to transfer $50,000 from a saving bank account to checking account. Okay, so there are two accounts here, saving account and checking account. We want to transfer 50,000 from saving account to checking account. We want to transfer $50,000. Okay, the first thing, 50,000 was deducted from saving, then it will be added to checking. So let's say that 15 is deducted from saving but not added to the checking account. This will lead to the database in an inconsistent state. Inconsistent state. There are two accounts, okay, of Mr. Firas. He has here 3,50,000 and $350,000 in one account, which is saving account, and in another account he has $10,000, which is checking account. He want to make a transfer of 50,000 from saving to checking account. So these are all working in the database, right? When you make a transfer, minus 50,000 is applied here. So what is remaining? $300,000, and it should go and update here plus 50,000, right? And the balance should be 60,000. Now it is complete. But our case here is that, let's say for example, it is deducted here, but while you are making update, some failure happened and there is no update here. So here there is a loss. So this will lead to what? The database in an inconsistent state. Okay. So the two major problem here is that the concurrent transaction attempting to update the same data item may affect one another adversely and produce incorrect and inconsistent result. Hardware or software malfunction could cause the failure of the database and ruin its content. So the failures can be anything, whether it is a software failure or hardware failure. But the problem is that we lose the data, we lose the content, right? That is a problem here. So what is the solution for this? The solution is this: to use the concept of begin, commit, abort, or rollback. Okay, and make the transaction as ACID transaction. Fine. So begin, what we will do, will mark the beginning of the transaction. So begin is a marker, will mark the beginning of the transaction. Read saving account, deduct 50,000 from saving account, write to saving account. That is after deducting what is remaining here. Okay. Then read checking account, add 50,000 to the checking account, write checking, then make commit. So begin will start the transaction, commit will complete, and save the transaction. Okay, now the database will be in a consistent state, that it deduct 50,000, then add 50,000 here, and 60,000 will be the balance, and 390,000 will be balance here. So in this case, the database is in a consistent state. This is a successful transaction. This is a successful transaction. What about an abort here? For example, let's say there is a hardware failure in between or a software failure in between. Anything can happen in between, network failure. Okay, so in that case, what will happen? Use abort and roll back. So for example, you started the transaction with begin, read the saving, deduct the saving 50,000, write the saving. So you deducted and you write this. After that, read checking account, add 50,000. Now, while adding 50,000, some problem happened. Can be hardware failure or network failure or software problem. Some problem happened, and this transaction has been aborted. Okay, so in that case, abort will have called, and abort will call the rollback, and rollback will just do the rollback of what is being done. So what is done here, minus 50,000 will be just rolled back. Yes, Firas. طيب a successful transaction. فهمت هذا successful transaction؟ ايوه، نقل البيان. هذا الابلكيشن بروجرام وهذا داتابيس، تمام، وهذا بروجرام. فايش البروجرام؟ نحول 50,000 من اكونت الى اكونت. ايوه الميكانيزم هنا اول ايش؟ deduct 50,000 هنا من saving account، وبعدين يصير رايت سيفنج يعني كمل باقي هنا. اوكي، وبرجع الى اكونت تشيكينج، ففيها 10,000 زيد فيها 50,000. اوكي، add 50,000 برايت تشيكينج which is 60,000 now. اوكي، commit يعني save. اوكي، زي السيف. او طيب، فهذا successful transaction. طيب هنا جاي هنا هذا aborted transaction. aborted transaction بمعنى انه في مشكله لما العمليه هذه، لما استمر هذا العمليه في الوسط العمليه صار المشكله، مشكله ممكن من الهاردوير، من السوفت وير، ولا باور لوس or network failure anything. اوكي، مثلا انت عمل هذه العمليه عن طريق التطبيق الجوال. اوكي، ايوه ممكن ما لا حتى ما يكون فلوس، هذا شيء ثاني. ممكن صار يعني ايرور في البرنامج نفسه فوقف البرنامج، او طفى الجوال، يعني ما في بطارية طفى الجوال فجأة، طفى الجوال. اوكي، او ممكن الشبكة يعني قفل او منقطع الشبكة من الجوال، فخلاص يعني هذه العملية نص العملية وقفت. في مجال هذه. اوكي، فايش الحل؟ لانه انت اول عملت هنا العمليه بدات من هنا من البيجن. اوكي، عمليه بدات من البيجن، فعملنا بيجن يعني ستارت. اوكي، ريد سيفنج، انا ناخذ السيفنج وبعدين اعمل 50,000 ديدكشن من السيفنج، فنجيب السيفنج الباقي 390,000. اوكي، عملنا رايت يعني update here. اوكي، بعدين read checking. اوكي شفنا التشيكينج وزيدنا 50,000 في التشيكينج. بعد كده نزيد لازم يكون رايت هنا. اوكي 50 يعني 60 لازم يكون رايت او كامل. فهنا صار المشكله. لما صار المشكله نستدعي الابورت. ابورت يعني خلاص في مشكله نوقف هنا العمليه، نوقف العمليه هنا. فدحين ايش الحل؟ نعمل ايش؟ رول باك. ليش؟ لانه عملنا هذه العمليه بس صارت هنا 3000 390,000. اوكي وال 50,000 عملنا ديدكشن من هنا، ولكن فين ال 50,000 هنا؟ ما زادت هنا، ما عملت السيف. فنعمل رول باك. فالرول باك ايش بيصير؟ رول باك بيرجع نفس العملية عكس. إذا زادت هنا نقص 50. اوكي اجى هنا ناقص 50 زود 50 هنا زود 50 يصير بيرجع لنفس المبلغ، بيرجع الاكونت على نفس المبلغ. اوكي فهنا باي ابورت بيرجع الداتابيس الى نفس الكونسيستنت ستيت. اذا ما في ابورت هنا فين ال 50 دحين؟ اوكي فهذا المشكله. فالابورت والرول باك بحل هذه المشكله بيرجع الداتابيس الى consistent state. Okay. Okay. So what we are using here, we are using this concept of begin, commit, begin and start, commit and save, abort, stop or stop the transaction, roll back, just roll back the transaction. Okay. So the key points of data transaction: a transaction is an atomic unit of work. Atomic يعني single piece of work. يعني أي عملية ناخذ عملية ك one piece or one thing. No, ما ناخذ جزئيات حق العملية، ناخذ ك one piece. Okay, if it is one piece, an atomic unit of work, it should work completely. It will succeed completely or it will fail completely. Okay, if it is succeeding, it will succeed completely. If it is failing, it will fail completely. Okay, so a transaction is an atomic unit of work. A transaction must leave database in a consistent state. It must either complete in its entirety or not at all, or not does not complete at all. The beginning and end points of each transaction must be marked by a specific statement. Data manipulation language provides begin, commit, abort, rollback that can be included in the application program. Begin, it means start of the transaction. Commit, the end of the transaction after successful database update. Rollback, end of the transaction after rolling back effect of unsuccessful database updates. Okay. When a transaction completes, two outcomes are possible: a new consistent state or partial database updates rollback and restored to the old consistent state. Whenever we make a transaction, the database will be in two states, whether it will be a new consistent state or it will be rolled back and it will go to the previous state. Transactions of the same program cannot be nested. Only while a transaction is in progress can commit and rollback commands be performed inside the transaction. So commit and rollback will be performed inside the transaction and not at the beginning of the transaction. Each transaction must be executed only once as written and not repeatedly. If it is start and end transaction are not marked with a specific statement, that is begin and commit, the database management assumes the beginning and end of entire program as the start and end point of the transaction within the program. The whole program will be considered as the start of the program will be begin and the end of the program will be commit. Okay, so this is about the points regarding the database transactions. Okay, so this is very important that any transaction that we make in the database should be atomic and it must leave the database in a consistent state, and every transaction should be marked by begin, commit, abort, and rollback. Begin means start of the transaction. Commit is the end of the transaction, successful end of the transaction, and we'll put this database in a consistent state. For rollback, it means it will roll back the transaction and return the database in a consistent previous state. Okay, and whenever there is a transaction, it will put the database in two states, whether it will put in a new state, that is after if it is a successful transaction, and or it will put in an old state if it is an unsuccessful transaction. Okay, so in your transaction programs, you should use commit, begin, and commit, and rollback wherever it is necessary. Okay, and the whole transaction should be considered as a one unit of job or one unit, okay, atomic unit. Properties of transaction. Every transaction must have this property called ACID property, which is atomicity. Every transaction should be atomic. Consistency, put the transaction should be in isolation, and the transaction should be durable, that it will stay in the database. So ACID transaction will maintain the consistency, correctness, and validity of the transaction. ACID, it means atomicity. Atomicity is a transaction said to be atomic if it execute all its database updates or none at all. It means that it will execute the whole updates as one piece of work, or it will not execute any update. That is an atomicity. So a transaction should be atomic. That's what it means here. Transaction is atomic unit of work. Then consistency, preserving the database consistency. The result from the other three properties, that should be that is the durability and isolation and atomicity, that the database should be in a consistent state after you make the transaction. Okay, whether it is a successful or unsuccessful for transaction, database should be in a consistent state. Then isolation, for the user, a transaction must appear as though it is executed by itself. That is, this transaction is made by the user, and only one user is making this transaction. No other user is making this transaction. In isolation, this should work in isolation. Then durability, the effect of the database update by the successfully completed transaction must be permanent in the database. Okay, durable, it means it should go long. That whatever we make the transaction, whatever they make the changes in the database from the transaction, that changes after the commit should be permanent, in the database. Okay, unless you make another changes in the same database or with the same data. So these are the ACID properties of transaction. So every transaction should satisfy these ACID properties. Okay, so we'll just do a walkthrough here, that every transaction starts with a begin. So it is only one transaction here, so that every transaction will be considered as atomic, right? One piece of work. This complete as one piece of work. So begin, read saving, detect saving from the saving and store in the saving 50,000, then write the saving, then read checking, add 50,000 to the checking, and write checking, commit. So this is a successful transaction, and this will put the database in a consistent new state. Okay, and it is atomic. Now here, through this transaction, let's say that there is an abort happen in the sense some failure, for example system failure or network failure, or or let's say, for example, software failure. Any failure happens, this should do a rollback. Just reverse the transaction till the beginning. Okay, just reverse the transactions, all the transactions till the beginning. So again here, the database will be in a consistent state, the old consistent state, that without making any changes. Into all these changes are discarded, it will go in this consistent state, the old consistent state. Fine. That is, so it is possible through atomicity. So it will be considered as one transaction. This is also considered as one transaction. Okay. So database will be in a consistent state. Okay, the database should work in isolation. Isolation, every transaction should work in isolation. It's not like that every transaction will work together. Okay, so work in isolation. If there are two transactions, this transaction should be work in separate, and this transaction should work in separate and not together. Right? So that is the main thing. So if it is the first transaction, make this transaction okay as first transaction and this as second transaction. Okay, one after the other. Durable, whatever we make the changes, there is a change in the saving account, there is a change in the checking account, this will persist or remain for ever or for long time unless we make another changes here. Okay, that is called durability. So this is the states of the transaction. The state cycle is given here. We begin the transaction is active. Now from the begin, we read some data, we write some data, like read 50,000, read the saving account, detect 50,000, and then write the saving account, then read checking account, then write the checking account. So there is a read write will happen. So now after the complete read write, that will transaction will go to the end, partially committed, then we call committed, and then terminated. Terminated is come out. Or this is successful. This side is it is successful transaction will put the database in a new state. Okay, so this part is a successfully terminated transaction. Okay, along with this one. Now here, while we are doing read write, there can be a chance that there is an abort and the whole transaction is failed. Then we should make a rollback and terminate it. This transaction is unsuccessful transaction and will put the database in an old consistent state, and it is an unsuccessful transaction. Okay, so this is the life cycle of the transaction state. So you can see here what we have. We have begin. We start with begin here. Then transaction will go to active transaction. Then there is will be read write. And once it is completed, partially committed, then committed, terminate. Committed means save. Then if it is abort, then the transaction is failed. You make a rollback and then terminate the transaction. This is the states of the transaction. Okay. So transaction consists of three phases: input phase, and our database interaction, and output phase. Input phase receives the message and parameters to carry out the necessary interaction with the database. Like for example, the account ID, the account number, what is the amount to be transferred, all the inputs that is giving to the database for the transaction. Database interaction, perform the database read write. Output phase, provide a message regarding the successful or unsuccessful completion of database interaction. It retrieve and provide data for the application program and update database. So three phases: input, where we give some data to the transaction database interaction, and then output. Transaction types, there are two types of transactions, that is read-only transaction, update transaction. In read-only transaction, we are just trying to read what is the data inside the database. What are the contents of the database? That is read-only transaction. Whereas update transaction, we are trying to change the state of the object or the state of the database by doing some updates, by doing some processing for updating the database. Okay, so there's the two types of transactions. First, give me 5 minutes. Okay, I'll come back. I'll take some more time. Come back. 2 minutes, inshallah. Okay. Now, types of transaction: read-only transaction and update transaction. As I said, read-only transaction is just to read the data, right, from the data, the contents of the database. So this does not make any changes in the database. Means it will not change the state of the database. The state will remain the same. So any number of read-only transaction can share the database contents simultaneously, because it is just a read only. So if there is more than one transaction, so transaction 1 from user 1, there is user 2 making transaction 2, there is user 3 making transaction 3, and it is only read only transaction in the database, so they all can make simultaneously, because it is just read only. They are just reading and not changing the state of an object, or sorry, the database. If you talk about the update transaction, updates change the database content, therefore they change the state of the database. So while processing update transaction, conflict could arise among simultaneous transactions attempting to update the same data item. Okay, as I gave an example, let's say that there is user 1 and there is user 2 who want to update student 1 information, okay, in the database. So user 1 make an update at the same time. If the user is trying to make an update, so they can conflict the updates here, right? So in this case, you allow either user 1 or user 2 to do the updates, okay, at once, okay. So that can be a problem. Operating environment, single user environment, there is no concurrency problem, because if it is only one user, he does everything, then no problem. Okay, there is no concurrency problems, no data integrity problems. Multi-user environment, there can be concurrent transaction, could give rise to transaction conflicts, because one user is making update, the other user is checking that updates, okay, or the other user is also making an update. So different users are making different updates, so that will lead to problems. Okay. So in a multi-user environment requires effective measures and techniques for concurrency control. Concurrency, it means more than one user is making update at the same time. So how we can control it to avoid the problems? There are different problems associated with. There are 4 basic problems that are associated with this. Okay, so that we will discuss here. There's also data granularity. Should be checked that level and the scope of database content need to be logged a given time, so that you can provide a consistency. Also, dependability of the transactions and the data. Processing the concurrent transaction in parallel must be transparent to the users. Availability, data must be available, kept available for all the users when it is needed. Failure to which will say that database is not available. Right? Integrity consideration, we also consider the integrity functions of the database, like for example database foreign key integrity, okay, referential integrity, or any other condition set on the data. So all this should be detected. So detect any integrity violation by transaction. If violation is detected, take appropriate action like rejection of operation, reporting the violation, or correction of errors if possible. Okay. Also check the domain integrity. Domain integrity, it means the rules for the data. For the data, for example, what will be the ID, what will be the name, what will be the cost, and so on. Okay. Referential integrity, that is a foreign key integrity. There should not be violation of foreign key integrity in transaction. So all this related to the data integrity. Business rules enforce any rules and procedures and triggers on the data. That is any functions they write on the data. Fine. So if you consider, for example, this database where we have a supplier part and supply and ship method, right? So here, uh, make sure that we have the domain integrity. Domain integrity, it means supplier ID will be under in the same domain. For example, supplier ID will start with S 001. So it means S a number, another number, another number, 3 numbers. So all these supplier IDs should comes under this domain, okay, in this format. Similarly, part number, if it is by like P, then let's say P001 like this. So it is P, then a number, then another number, then another number, 3 numbers with P starting with P. So all the part numbers should come in this fashion. That is a domain of part number, domain of supplier ID. Then referential integrity, that is we have supplier ID, part number. These are the foreign keys from part and supplier. So the values here should be values here. That is the values here should be a part or a subset of the values here. And the values of part number here in supply is from taken from the values of part number from the part. This is referential integrity. Okay. Any other integrities that we set, for example, part weight cannot be null, so we set not null. Fine. That is also an integrity that will check this part should not take null value, part weight should not take null value. Okay. Supplier ship code, here ship code is a foreign key here, where is the primary key here. So let's say for example ship code will take all the data from here, that is referential integrity. Okay. Unit cost should be numerical, so it will check that whatever you enter here unit cost should be numbers. That is also an uh, you know the integrity, fine, rules set on the database. So all this should be checked to make sure the data integrity, the integrity of the data. Fine. So this is all about the integrity of the data. So we talk about this in terms of transaction, that is transaction support. Okay. So through transaction support, the integrity of the data is been maintained. Okay. The next is concurrency support. Concurrency support, as we discussed, that if it is a single user, no problem, the transaction will go user. If it is an individual user interacting with the database, then it will not have any problem. But if it is multiple users, there are many users, problem can arise when many users wish to access the database at the same time, which will have consider the concurrent transactions. Fine. So here the aim is to enable a user to complete a transaction, so effectively isolated from other within a transaction. So once the transaction is complete, another user may subsequently change the database. So the isolation is only partial here. Right? Once the transaction has been complete, the other can make the changes in the database. Right? So here the problem here is that if there is more than one user is accessing and updating the database, fine, changes can be done, right? Changes can be partial. Okay. So a simple way is to allow only one user to execute a transaction at a time, which is called serialized execution. So if it is multiple users, many users are doing this transaction, one method, a simple method is what? Allow only one user at a time. Allow only one user at a time. Okay. So this is not practical because one long transaction would prevent all other users from accessing the data. So what is wanted for DBMS to provide isolation equivalent to serialized execution, yet with concurrent execution of transactions. So you should provide isolation to every transaction which is serializable. Okay. If this degree of isolation can be achieved, we say that the execution of concurrent transaction is serializable. Serialize, it means serialize the execution one by one, one after the other. Okay. Implementing the serialization or serializable transaction involves locking the database. So a DBMS process a concurrent transaction by marking a data involved in the transaction as locked. If another transaction need to access this data which is locked, it is forced to wait until the locking transaction is completed and the data is released. Okay, data is released, it means data is unlocked. So for example, there is one transaction by user 1, there is another transaction by user 2. They want to make any changes, like say for example in student 1. So when this transaction comes in here, it locks the data of the student 1, or it locks the database. When user 2 want to make these changes, he has to wait until the user 1 completes and unlock this data. Then the user 2 can do any other transaction. This enables DBMS to provide a complete isolation for each transaction, and within a transaction and overcome the concurrency problem described. Okay, so locking is too strict. It can be done. Too strict locking, it means that the transaction may have to wait for a long time before the locked data is released, and it can continue the execution. This problem can be elevated to a certain extent by considering how the 4 problems of concurrency may affect the transaction. Okay, some of the problems may not serious problems, some may be serious problems. So serious problems, we can provide a high level of or a strict locking, and whereas not serious problems, we can give some relaxation. So the isolation levels, the level of concurrent access for a transaction is determined by its isolation. The highest level of isolation is known as serializable isolation. It means isolating the transaction, separating the transaction. Highest level is serializable, which guarantee the serializable execution of transaction. And lowest level isolation may result in one of the concurrency problem. Okay, so note that no isolation allows lost update to occur within a transaction. So how we set the isolation level? In SQL, we use this statement, set transaction isolation level to the levels. What are the different levels? Serializable, where the data is completely locked. Okay, and it is the other transaction has to wait till this is open. Or it can be repeatable read. Repeatable read, there is a possibility of reading the data but not making any updates in the data. Or read committed. Read committed, here it means that any data it is committed, the transaction can read the data. If not committed, cannot read the data. Or read uncommitted, here the transaction can read the uncommitted data also. So this is a low level of isolation, and this is the high level of isolation. Fine. So the 4 problems that are discussed with this concurrent transactions: lost update, that is whatever the update made by the one user may lost by the another user. Read uncommitted data, dirty read. So some user is making data transaction and you are reading in between the transaction, which is not committed, right? So uncommitted data, non-repeatable read, or phantom rows. Fine. I ask you to go through these problems of transaction, concurrency transaction. I want you to read about this from the activities. Okay. Then database failures and recovery. Database can fail. Okay. Uh, so some problems may arise with the data because of the database failures. So it is the job of DBMS where will recover the failures, that is by reinstalling the backups, for example, or reinitiating the backups. Okay, and recovering from these failures. Query processing and optimization. It means whatever the query we write, the SQL query, this need to be executed, all right, and we need to write an efficient SQL query. Okay, and these query need to maybe optimized by the DBMS to see there is a less resources are being used, while processing the queries. Indexing are data structures that can help us to retrieve or change information in the tables, okay, efficiently. So you can study about this indexing and these activities 12.7. So indexing is an important thing here, okay. I'll take you to that 12.7 here. See here, problems of concurrent transaction. Describe types of problem associated with concurrent transaction and explain how they can be avoided. Describe serializable and recoverable transaction. Explain how log-based technique resolve concurrency problem. All these you read from the chapters of Punaya, that is chapter 15, okay, from page 56 to 78. I want you to read this, okay. So here, take you, where is that? Yeah, serializable execution. Transaction and submission serializable and transaction. Indexing. Fine. So what is indexing or what is indexes here? An index is a data structure that makes it efficient to retrieve the objects given the value of one or more elements of those objects. That is, through the indexing, we can retrieve the data, we can retrieve the objects. If the objects are row of a table, then index is one or more column of the given table. For example, we can take primary key as an index. So using index, you can retrieve the objects. Like for example, you have a student table, okay? And there is a student ID, which is primary key. So you can use index as ID. So using ID, you can access the object of a student, right? So that's what given indexing here. Given the values for those columns, the index will let us retrieve the rows that matches those values efficiently because we do not have access to tables to find the matches. So a good analogy is that index of a book. You see the book, inside the book there is an index. So this index will help you to find the contents inside the book, the topics inside the book, the page numbers of the book where the topics are discussed. And if this topic is not available in the index, meaning that this data is not available in the book, right? So this is how the index can be used in the databases. Okay, so we can also create an index on a foreign key columns. Search for matching primary key and foreign key values would for every primary key value check whether the value exists in the foreign key index or not. Only then access the table where the foreign key is defined to retrieve the matching rows. So we can also define the indexes on foreign key and check that the foreign key, the values in the foreign key exist in the primary key of the referenced table. Okay, so this also be checked here. How the indexing will help in joining the tables using this for the indexing. Like for example, in a customer table, I use customer ID. Okay, and in an order table, I use customer ID as a index, right? So using the index, like while from customer join order on customer.customer ID is equal to order.customer ID. This is using these two indexes. We are joining these tables, okay, and we check the condition on the later condition on total cost. Fine. So this also the join will help here. The indexing is helping in joining the tables to retrieve the data from the database. Okay. So how this will work? First thing is that the from clause is executed, customer join the order, so it will produce a product operation. It will produce all the customer and their orders. Okay. Then on customer ID, will select only matching customer IDs. So it will be only matching customer IDs in the customer as well as in the order will be selected, where then it will apply the where clause where we have total cost above 100, fine, and then it will go for a select operation. Right. So to minimize the resource required to execute the select query, it is necessary to reduce the amount of data to be processed. Right. So the efficiency of the product operation, where all possible pairs of row from two tables is produced, is depend on the number of rows each of the two table has. The size of the order table could be reduced by executing step 3 before step 1. That is by executing the where clause before executing the from clause. This will reduce the size of the from the size of the order table. Okay, so that is optimizing the queries. DBMS will optimize that. Fine. So here our concern is indexing. So index can be used here to find the data objects. Fine. If it is a tabular data, we can use the primary keys as index, and also foreign keys can be used as index. And using index, we can have efficient join while joining the tables. Fine. And DBMS can optimize these SQL queries to process it quickly. Okay. So go through the exercises also. That is also important here. Where we are. Yeah, we were at indexing, right? So we did the indexing, and improving the performance of search condition. We just saw that using indexing we can join the tables and increase the performance of the select. Okay. Query processing. It is how efficiently the query has been processed. We just saw that in the last slide that whenever the query is executed, it processes the data. So when it is processing the data, it has to look at that how much of data it is processing. So try to reduce the data so that the query will be processed quickly. That is what here the query processing, right? It is about optimizing the process, optimizing the whole process, okay, and using less resources. Fine. So this is all what we have here in this part 12 of data integrity. Okay. So as a summary, in this part of data integrity, the main thing that we talk about is about a transaction, the atomic property of a transaction. Then we talk about the concurrency in transaction, the four problems of concurrency in transaction, and how the isolation will the serialization, the serializable or serialization and isolation will help to solve the problems of concurrency. Okay, that is the important thing. Later we talk about indexing, query processing, and other things. This is just you have to have a look on these also. Fine. So go through its activities and exercises, which are important to understand these topics. And we'll stop here for today. And if you have any questions, please ask. Next week we'll take part 13 and 14, inshallah. So if you have any questions you want to ask. Yes.